This is Algebra 2, Chapter 8, Section 4, in which we will graph rational functions. All a rational function is a rational expression written as a function. It'll have f of x equals, and that's what you have for a rational function. The key to being able to graph these things is to find the zeros and to find the asymptotes. Now, we talked about last time there's two kinds of asymptotes. There's the vertical and the horizontal. The vertical asymptote is still the same idea. It's where the denominator is equal to 0. Now, with the horizontal asymptote, you have to look at the degrees of the numerator and the denominator. You have to look at the highest power that each one has. If the numerator's high power is greater than the denominator's high power, then there's not a horizontal asymptote. If the highest power you have is on top, you don't have a horizontal asymptote. If the highest power is on bottom, if the numerator's power is less than the denominator, then the asymptote is y is equal to 0. And then if the two both have the same highest power, then you look at the ratio of the coefficients. And I'll show you one like that here in a few minutes. Okay. One thing that's key to understand with horizontal asymptotes here, they're not like the other ones that we did last time, in that your graph can actually cross that line. What's going on is what's happening way out far to the left and far to the right. And I'll show you what I'm talking about here in a minute. Actually, I'll show you that in class because we use the graphing calculators to do the heavy lifting. Okay. So our job is to graph this function. And like I say, we'll use the calculators to do the heavy lifting for this. But we're going to need to find the zeros and find the asymptotes. Okay. For the zeros, you set the numerator equal to 0. Well, that's something we know how to factor, or set each one up. So those are our zeros. Okay. Yes, I know this doesn't distribute back out to that. Remember, we did the step where we divided out the common factor. I just left that step out here because it wasn't going to matter. So we have our two zeros. That's going to put 2 points on our graph. For the asymptotes, let's do the vertical asymptote first. So we set the denominator to 0. We factor it. And we solve, and that gives us two vertical asymptotes that the graph can't cross. It can cross horizontal, but it cannot cross vertical. For the horizontal asymptote, we look at the highest powers. They both have a power of 2. So our rule said if they're the same power, then you do the ratio. The ratio is 2 over 1. The numbers that are attached to those highest powers are the ratio you use. So 2 divided by 1, which is 2. And like I said, we'll get the actual graph from the calculator. But we're going to have these things already marked on our graph that you're going to draw for me so that you can use that to help with the drawing part. Okay. There are other kinds of asymptotes besides the vertical and horizontal. One is called an oblique asymptote. You'll probably hear me call it a slant asymptote. That's the term I was taught. But these happen when you don't get a horizontal. Remember, if the degree on the numerator was higher, you don't get horizontal. Well, when degree is exactly 1 higher, then you will get an oblique. Okay. Notice here we have x cubed and we have x squared. There's one difference between them. To get our oblique asymptote, then, we need to divide the bottom into the top. Okay. And you'll notice I put this 0x term in because it was missing, so I put it in there to hold the spot. Now we have to do our long division that we learned how to do earlier. X squared goes into x cubed, x times. Distribute the x to those, and we get x cubed minus 4x. Notice I line them up under the terms that they make sense to line up with. When we subtract, that cancels. That will become a positive 4x, and the other terms will just come down. Okay. X squared goes into negative 2x squared, negative 2 times. Negative 2 times x squared, negative 2x squared, plus 8. And then when we subtract, we get a remainder here. We don't really care about the remainder. The oblique asymptote is the answer that we got from dividing. Okay. This would be a diagonal line. And so out toward the edges, the graph is going to grow toward that line. And you'll see that when we use the calculators in class. Now sometimes these things have common factors in the top and the bottom. That is to say, you could simplify the problem. In those cases, what you get is called a point discontinuity. And those cases, you get a hole in the graph. And I'll show you one like that on the calculator in class. I'll show you what it looks like. But let's find our point discontinuity. We're going to need to factor the numerator. Now, just like we've done before, let's cancel what's in common. So now we have a new function, x minus 1. Okay. Now, I'm going to erase my canceling. What would make our denominator 0? Negative 5. Plug negative 5 in. Negative 5 minus 1 is negative 6, so we have a point at x equals negative 5, y equals negative 6. That's a point discontinuity. Okay. The graph is going to have a hole at that location. Let's do one more. We're going to have to do some heavy lifting factoring because I see 4 terms. So that probably means we're going to do grouping. Yep, sure enough, we can take an x squared out of the first 2. Can take a negative 9 out of the second 2. Okay. That becomes x squared minus 9 times x plus 2 over x squared minus 9. Well, look at that. Those two things are identical. I'm going to go ahead and factor them so I can see all my discontinuity points coming up. You can see these cancel out, and you can see these two cancel out. So you're left with x plus 2 for your function. Now, where do our discontinuities come from? At x equals negative 3, and at x equals 3. So I'm going to plug negative 3 and 3 into this function that they gave me. Negative 3 plus 2 is negative 1, so I have a point at negative 3, negative 1. I get a hole there. 3 plus 2 is 5, so I get a hole at 3, 5. Okay. Now remember, we're going to use the calculators to do the heavy work of getting the actual graphs. What you're going to have to do on your own work there is find me zeros, find me asymptotes, find me oblique asymptotes, and find the point discontinuities. If you had questions along the way, hopefully you wrote those down. Bring them in with you to ask, and we will see you in class.